to say a few words about this event. Now, if I could just introduce what we thought that it would be about. We originated the idea of this event last summer, and in fact Paul Finch and Frank Duffy got together with me, and we decided that it would be good to have some discussions and some exchanges on some of the key questions and issues that we're facing in architecture today. And they're discussions which we hope would engage as wide an audience as is possible, and which would use the AA in one of the ways in which it traditionally has been used, that is, as a meeting and discussion centre for architecture. So tonight's forum, which is the second in this series, will be examining the theme of structural expression in architecture. And so for this evening, we've tried to assemble through invitation, through coercion, through fair means and through foul, as many architects, engineers, teachers and students, and of course all interested people who've got things to say about those sorts of architecture that have come about through different formulations of the idea of expression of structure. Formulations which might, by some readings, be seen as being governed by, for example, technological rules alone, that is to say, by some sort of internal logic, while in other readings it might be seen as being governed by ethical rules. And we might remember Ruskin's lamp of truth, which was so important for the modern movement, and through which it becomes nothing less than an immoral act to use materials in an extravagant or in an arbitrary way. And of course, we might notice that this ethic is often found also accompanying this same logic. But another and currently common reading tells us that the expression of structure can be, and often is, conceived of as an aesthetic, sometimes quite openly defying at least the ethic, but also sometimes defying the logic, while being the result of a private, subjective, aesthetic criteria alone. Anyway, this sort of description doesn't exhaust these sort of possibilities. I'm just trying to sort of indicate some possible ways that we might open up this discussion. So I'll try to not say very much, but just sort of add that expression of structure as we are posing it tonight, I hope is not just a pragmatic problem. You don't just have to do it, as it were, in an uninformed way. When we pose the idea of structure expression, I think we're engaging with or taking part in one of the major discourses in architecture. One which has been evolving through such disciplines as engineering, architecture, or, as we heard last week from Robert Thorne in one of the lead-up lectures which we had to this evening, through structural engineering manufacturers and fabricators. And he was talking about early 19th century fabricators, but I think the same is true in different degrees to today, all helping together to make technological discourse. Architects then are only a part of it, and I think that one of the opportunities this evening is to see what part the architects play in this enterprise. So I would like to feel that tonight we're going to assume that we're holding these discussions then about structural expression in architecture within a framework about which we might ask you to consider whether this enterprise, in some form or other, appears to be alive and well, or whether you believe that it has new directions to go, or maybe everything is just fine as it is. So let me just then stop at this point and just say that the model for our meeting this evening is to ask several people who we have invited to speak to talk for a few moments, 10 minutes or so, to show some slides, and then to open the discussion to you all. So the intention then is to try to make it, if possible, as good an exchange as we humanly can, and we'll do everything we can to gain access to everybody, and we'll see how it goes from there. Now, I think that maybe, I wonder if I could start by asking, what about asking one of the people who've been helping to work this project out, although he doesn't know he's going to be asked, although I think he's got a hint, that Frank Newby, what about saying a few words and maybe...
What?
You didn't load the slides though.
Oh, have you got a slide loading program?
We're in a common camp.
Can you? Are we going to be determined by the way you've loaded the slides?
Probably.
Well, okay. No,
I'll talk about the slides that come on.
He doesn't mind which slides they are.
Said that was going to happen.
Okay.
Okay, Frank, we'll try and find the beginning.
Okay, right, fine. There are only 6. The reason I've been asked to start is that I'm the oldest.
Or not.
Oh, that's true, sorry. Oh, you've retired.
Dead.
I wanted to illustrate...
Is that you?
That's me, back to front, it's all right. Still standing.
I know that.
Is there one before that, Frank?
No, that's fine. That's back in the 50s. In fact, in '49, I joined Samuele, and after the war, materials were very short supply, and there was a movement towards filter plates, space construction, which now is known as monocoque or semi-monocoque, whatever that means. I was showing, in fact, a slide of the sort of lattice steel shells that Samueli was producing at that period. They were pure structure, economic, and the architects tended to accept one of a number of schemes that we might propose to them. We go on to the next one. No, it's the wrong way.
Well, that was
Hey, that's fine. That's
That's better.
Yes, worked with Theo Crosby on the UIA pavilion, which is folding 12-gauge sheets of aluminium and into tetrahedra and connecting them together with compression tubes at the top. Again, showing how folding material you can produce stiffness, and so you can produce a structure. And this is one of, as it were, many possibilities. Once you go into 3 dimensions, you've got so many kind of ways of doing it. It really comes from a discussion with the architects of, for an exhibition, what would you like to do, which you've never done before, and this turned up. And next, you wouldn't call it structural expression. This is so here we have, in fact, a few years later, with Cedric Price, the birdcage at the zoo, where I was wanting a structure which appeared to be floating in mid-air and influenced by Bucky Fuller and tensegrity. There were quite a number of possible solutions. We made a model which worked. Then when we started calculation, once we got the job, found that one of the cables to the ground was in compression. I realized that when we made the model, we pretensioned the cables for the structure. So in fact, I pretensioned a member so that it could take compression. So that visually, there's a member, a cable, which is actually taking compression. A reduction in tension is compression. Therefore, engineers, when you have particular types of structures, or redundant structure, as one member too many, at least one, then you can pre-stress the structure and put in it man-made stresses, which you in fact add to stresses due to normal loading, so that it's possible to produce structures, and this is just one example, which don't look as though they should stand up, but they do. The next slide, please. This is a doodle which illustrates the fact that the bottom one is a pure structure where the loads in members, if they're compression, they're tubes, and if they're in tension, they're cables. But there was an architectural decision, and Cedric's not here, he's hiding, to have tetrahedra at the top, suspended in mid-air, as against having at the bottom 3 members in compression in tubes and other tension members, as though you had a complete tension net around the structure through which you looked at the bird. If you then can have tension members either in tubes which could take compression or tension. Therefore, it's up to, in a way, the architect to decide what sort of expression of the structure you're going to have. P. Cook at Bath the other week said he couldn't care less. In fact, if it was an exciting structure, he didn't mind whether it worked or not, and it didn't really matter what loads went here or there. So there's we as engineers can, one, manipulate the loads in members in certain cases. Also, you have the opportunity to change the kind of visual form of a structure in that particular case. Again, I don't think it's structural expression as we are trying to define this evening. The next one. And we're having the IBM at Hursley with Grimshaw, which was an exposed structure, slightly overbraced from a structural point of view, but this, I don't know whether you call it high-tech or not, but the structure is being slightly used as decoration. Not to a great extent. You have, in fact, portal frames of latticed space frame structures spanning on the outside, because Nick on the inside wants a clean, smooth finish, and there's a single skin metal deck construction between the structure. The structure was becoming exposed, and I'm not quite certain whether structural expression is exposed structure. I think not. I think it started this way. I think it's slightly more than just exposing the structure. And the next and last is a leisure centre at Doncaster, where the architect has emphasised the structure, and if you can see it clearly, but you've got kind of capitals made out of RSJs with holes in, and really I didn't have a great deal to do with it. But it does raise a question of whether you have to distort or over-express structure, overdo structure in order to express it. And I'm interested to kind of remarks this evening as to how you create excitement. Do you in fact do you distort the structure? Do you add in kind of tension nets and so forth? What is the architect's idea of structure, of expressing structure? Because I don't think it's pure structure. I think it's almost anti-structure or impure structure, where you start getting excitement. Thank you.
Right, thank you. Can we have the lights on? Right, well, I wondered if we could also... I do know that James Sutherland is particularly interested in this particular period of time, and or the early period of the 50s, and the architecture and engineering, which was the product of the 50s, and I think you also might be able to feed in something about this.
Okay.
Could you do
yes.
that?
Can you hear? Actually, Mark, have you got my little bundle? Well, they're not quite ready yet, but... well, anyway, let me start. I want to look back on the 50s and 60s, when we didn't actually... We really were looking at pure structure, I think, most of us. We were expressing the structure as such. And I'm really trying to ask questions about this. We didn't do it consciously as a style. We did it partly because of material shortages. We did it, I think, because of a religion of functionalism, which many of us believed in. It really was a very strong religion. And to some extent it was aesthetic, but again, I'm not certain, how it looks today. Now, what I really want to know is, I want to show about 4 or 5 slides and see, I'm very interested to know what people think of these today. And I'm particularly interested in people under 40. I mean, no one of my age, I don't, we're all so tainted with it that it doesn't matter. Could we start, Mark? So there's a very old, crummy slides, the first two. They're sort of... this is the sort of the post-war school period, when we were actually cutting things down and down and down and down. We used almost no steel, and we pre-stressed everything. We had crazy structures sitting on 150 square columns, and then we chipped away a lot of them with 3 stories on top. And we we really, actually, I think we're rather proud of what we were doing. But I think today they look rather mean. Let's go to the next one. And they were sort of awful little sort of tinny-looking shed buildings, I think now. But I'd like to ask a question about this in the end. Next, please. I remember looking at that thing and saying, my God, those things look terribly heavy, don't they? Couldn't we get those columns a lot slimmer? But now I look at it again, and I think they looked rather spindly. Next, please. I mean, sometimes we actually produced a bit of drama, but I think it was spoilt by sort of the sort of rather miserable materials we were working in. Next, please. And it was all sort of wood wool, and and it was terribly honest and straightforward, but I think it looks a little mean. Now, next, please. If we then look back 100 years, and we get something which I find incredibly beautiful. And this is a minimal structure. It's a minimal structure, next please, of enormous slenderness. And if you just look at those columns, they're incredibly elegant. The whole thing is elegant. Now, what my real question is, that, I think, is a sort of cult structure by today's standards. Now, will the 1950s, 60s structures, which I showed, become cult structures in 25 years? Or have they started to now? Or will they never? I really actually want, I'm not offering any opinion on this, I just want actually to see if others, particularly younger people, would give me an idea on this subject. Because I'm a bit worried about our pure functionalism now, but I would very much like to hear what other people think. It might suddenly become a cult.
Could I just interject? Is that the one in Regent's Park?
No, it's the one in Kensington Gardens.
Oh,
No comment.
sorry.
Well, James Sutherland has invited anyone under 40.
Well, I prefer... No, not necessarily under 40. Anybody, honestly. But it's particularly like to see what, because there's more chance of finding out what people will think in 25 years' time if we got the 20-year-olds now than if we get the 50-year-olds now.
It's just that they put one up in Regent's Park a few years ago, exactly the same as that, brand new. I just thought it was interesting.
I mean, that is a cast-iron column. I mean, and there's no bracing in it at all. It's incredible structure.
Do you mean it's unstable?
No, no, that's the whole point. It is not unstable. It stood the gales in October 87, and it withstood the recent ones. But I doubt whether you could actually get it through any modern building control officer now.
A question from neighbour 60.
Can you speak a bit louder, Gordon?
A question from an over 60. Whatever. Are the columns water-filled?
Which, those ones,
Yeah.
are they wanted?
Are they water-filled?
Water-filled. Not deliberately.
No. Well, I'm not sure. I'm not sure that they aren't drain pipes. But they're certainly not water-filled for fire resistance. No.
No, for proper resistance. I mean, as in many buildings. But, that is simply an interesting question.
No. Well, no, I think
Particularly in connection
I think if they got water-filled, they would crack in the frost. But that's a...
No, if you had glycol in there, they wouldn't.
Okay.
If you had distilled glycol in them, they would not.
Oil.
Oh, oil them. No, well, I don't think they need anything in them. I don't know quite what. They're very happy the way they are.
Very good. It's simply an engineering point.
Well, yes, except that they have actually a little bit of, at the bottom and the top, of a little bit of bulge, a little bit of ball, and
Yes.
they're somehow, that they look to me incredibly elegant. The things we were doing with straight tubes in the 50s
Yes.
don't look so elegant. Now, I don't actually quite see, I mean, it may be that they're just too recent.
James, have you actually produced any calculations to show that they wouldn't stand up under modern methods, even with ultimate lead?
These?
Yes.
No, I haven't, I freely admit.
What a pity.
Right.
Perhaps the columns aren't actually important in the pavilion you described. Perhaps what's important is the roof floating in the park, and the columns actually have no significance at all, except that they need to be there to hold it up.
Hold it down.
Yeah, but it's the sway on that which I would be worried about. But I think whether structurally it works or not isn't very significant. What does, I think, is interesting is whether the 50s, 60s ones are just too recent for us to see straight, or whether, you know, they're all right, or whether they're just rather mean and nasty. I don't know. I'm interested.
Isn't there something rather fabulous about the 40s and 50s, where we were under such pressure to use no material at all, perhaps? And this kind of pressure on you and us, engineers and architects, was so extreme that some of the most fabulous forms actually were generated. And things like all those sort of shell barrels, all those funny wooden punt systems, or all those absolute minimalist sort of zigzag beams and things. And it was actually very exciting to work in a kind of pressure which forbade
Yes.
excess.
I totally agree with you, and I find it very exciting, and you find it exciting.
I do, yes.
But what I want to know is, was the results worth it?
Yes!
All right, right, one answer.
Because one achieved an enclosure with the minimal,
Yes.
a maximum of effort, but a minimal minimalisation of material. And isn't that what architecture and engineering is all about?
Ron? I think just as someone that was a student in the 50s and not practicing until late, if running parallel exactly with that was another sort of architecture which was to do about heaviness, and it was to do with making things bigger if necessary. There was a sort of expressionism in them, but it was an exaggeration. You were mixed up in this later. Yes, you were. Later, this became known as the New Brutalism. And I just reminded of that, the New Brutalism, an ethic or an aesthetic. To quote the Smithsons. But I think it's interesting that often in history we pull out the thing that we remember best, but in history all those things go on at the same time. So I don't think it's very important that the audience under 40 or under 30 realise that the 50s weren't necessarily totally about fining down, making thin. And even I mean, the things that Sams were doing in the 50s were not necessarily matched by other engineers.
And I think it was the late 50s, in fact, after the festival, which was a thin period. Then, in fact, in the 50s, then you started a reaction to that, was in fact the heavy.
No, but always, frankly, parallel to it, there's always something. I mean, at the moment, you could say that things are about lightness or transparency, but not everything's about that. I mean, everything happens. I mean, everything's going on at the same time. So I think you're pulling out something to explain your thesis. I don't disagree. I would never dream of disagreeing. with Frank.
Why? Why?
No, well, we are talking about structural expression.
Oh, I know.
You're trying to define what it means, and in fact you pull out things to illustrate that particular idea. Yes, everything was going on at the time.
I'm afraid, as a well over 40, whose views are perhaps invalid about those schools, yes, I think they are mean and dismal because they people try to excise expression from them. They're actually slightly, if I may say so, subhuman. They deliberately try to expunge this element, and I feel that that is what their meanness is about.
But you see, I was brought up on this so-called thinness, and it was as a result of going time and time again to the Festival of Britain, mainly because of the structures, which I found fascinating, much more than anything else.
That's right.
I mean, there were some absolutely superb ones. I was quite young then. As a result of that exhibition, I'm going to show my age now, I actually applied for a job with Samueli and got one. And it was at this time of thinness and lightweight taut structures, some of which, looking back on them, weren't necessarily very appropriate for their purpose, but some of them were very exciting, and from an engineer's point of view then, and to a certain extent now, but in perhaps a different way, they were wonderful things to work on because they were a terrific challenge. And I can remember one particular instance of a three-storey, very lightweight, steel frame building. It was a school, actually, Alston, if I remember rightly, which had precast concrete floors, which are specially designed, one of Sammy's favourites. And that was the most wobbly structure you could possibly imagine until you got the last bit in, as it were, and then it all locked up beautifully. Now that's not perhaps, I mean, not necessarily anything to do with architecture, although it is, because it was a piece of architecture. Can't remember who the architect was. Still on the Eastwick Field.
It was county architect, but
county architect.
the columns were 100 millimetres square, going up 3 or 4 stories.
That's right. This was actually because the engineer who designed that building went sick, and I arrived in the office that week. I had to take it over for a short while, and that was a sort of blooding for me. And it's made a very great impression, you probably realise, because I'm talking about it so much. And I went on and I worked for Sammy and Peru for 7 years. And then I went on to do things on my own, as it were, and I'm interested, actually.
Deep Lincoln.
Oh, I don't know, actually. Maybe I haven't. I think some people think I haven't been deep Lincoln. I'm, of course, interested in pure structure.
Could I come back to
It's not part of the conversation.
I think you're all going to have to talk a little bit louder because people back, I don't think, are picking up much of the conversation.
Oh.
Can I just reply
To these
Ron Heron's comment about the juxtaposition of new brutalism after the period which I was actually referring to, which was the post-war economy period, which actually happened just before the Smithsons won the Hunstanton school competition. The Hunstanton school competition was a product, really, of that post-war economy situation. Then they themselves reacted to that, and not altering their theory, but altering their forms, which actually became heavier. Now, whether this is in any way to do with structural expressionism, I doubt. I think it's forces much more than the forces of pure structure that brought this shift in brutalist theory of very subtle forces and very dramatic forces. So I think the brutalist buildings, which both Ron and I have been involved with, are a separate issue to my excitement about the minimalist buildings immediate post-war.
Yeah, no, I think the thing that's interesting, though, if you take the brutalist building, they were very simple. I mean, usually structure was a column and a big beam, and it was concrete, and you read it as a material. So somehow you could argue that the architecture did derive from the engineering, although the engineering was often exaggerated.
Thank you.
Which is to agree with Frank, as I said.
Perhaps it would be useful to expand or concentrate on the word expression
Yes.
at this stage. There's starting to be used, and if we set up like, and we're only in the 50s.
Oh, yes, we're going to. we were going to try.
If we talk about the difference between the thinness or the brutalness, which again
Yes,
might come back to an engineering thing, but are they both talking about expressing the same thing? And the expression as such isn't a ubiquitous thing. It's what you're trying to express, and whether the architectural or the engineering aspect of it actually is expressing what is the difference between them in terms of what it's trying to express.
I think we might actually get a little bit to the present practice, and might be a good idea to get Nick Grimshaw here to give his little thing, so that we can at least begin to get a picture of how we might be thinking about some of these same issues. Cedric Price, sir.
I was coming in while Nick was bringing something up. I didn't know it was going to be all our 40 years ago.
we had to.
I like Frank Newby on calculated brickwork. Where he managed to lower the Monadnock theory to 3 or 4 floors, 17. Very interested about weight and everything. Yes, I can sit back here and listen to Nick. Get a bit up to date.
Have you got them?
Have you got the slides? Very old.
Have we got the slides, please?
All right. Yeah, that's fine. Let's push the chairs together.
Mark, it's two,
No. Two. 3 on 2. I mean, okay, that was there.
10 in each one going parallel. Put them on top of the projectors and press the button. Have they just got 10 of them?
Yeah. Each with 10 slides. Barely.
There are 2 carousels.
Or if there's one with 20 in it, they may have put them all together.
You had your own carousels. Is this?
Spring out the metal.
Is Dennis there? I gave him to Dennis. Gone home. Oh, that's one of them. Yes, that's one of them. That's nice.
Right.
Have you? So they're all in a sequence, are they? Right. All in a box. Is that another 10 there?
Was that 2-inch stem?
It's a minimalist structure.
Oh, that's good.
Right.
Can you see that?
Do you want to put the lights down there? Well, look, I just worked out we wouldn't be getting to the 90s until 20 past 10 at the rate we were going. But, so I'll try and be quick. I thought this was quite a nice juxtaposition because both these buildings are doing exactly the same thing. And they're both water towers. And on the right you've got the what you might call the Prince Charles version, I suppose. On the left you've got the one which is really pure structural expressionism, in my view, with the load, coming down that central column and just delicately propped around the outside. I think, to me, that left side is what structural expressionism is. You can have the next one. Next. This is building of ours, the Financial Times, and again, I hope And I think that the columns, which also support the roof, and which support the roof and support the glazed wall, again, you can see what they're doing. You can see the arms sticking out and holding the glass. And I think that, again, you're getting almost everyone that goes past that building can actually see what's going on. And I think there's some merit in that, to my mind. Next. This was, there's another couple of slides on this. This was quite an interesting little problem. Talking of cheapness, we had to do a workshop in the Docklands which had to be absolutely dirt cheap. And we had to cover a 10,000 square foot workshop without any columns in it, because they were driving very heavy vehicles inside it, and if they'd ran into a column, the thing would have fallen down. And we spanned it with these 200 diameter tubes with just very light cross bracing and very simple joints. I think just if we just have a look at the next one, you can next page. Yeah, that's the effect. But I can't say I wasn't influenced by pottering around Cutty Sark, which was just on the other side of the through the Greenwich Tunnel. But it gave what was an absolutely basic. Talking of those early buildings, I bet this was probably as cheap as any of those. An absolute basic sheet of Wrigley tin with some very minimal amount of structure over it. But it did give it some sort of lift, doing it in steel rather than hidden concrete. Next one, please. Well, again, I think that it's fairly easy to see what's going on here. You've got tie downs, very heavy tie downs, on the outside of the building, which in fact we had to have a heavy retaining wall all around the site. So those concrete lumps stick out of the retaining wall. So we're using the retaining wall as a sort of added weight to hold down the perimeter of the building. And then there's the sort of rocker arms support the central arch. I think it's 42 metres between the columns. And again, we had to have clear span because of the operations inside. Next one. Well, and you can see what's going on from the end of the building too. You can see the arch expressed there. Running.
It's an arch or a truss?
It's a truss, Frank.
Thank you.
I'll come back to the bracing later. If you think about it, if you have a 4-bay structure, you can brace 2 of the bays together to stand up, and you're left with an odd one. You wouldn't like you say don't put the bracing in the odd one. I say really, to hell with it, put it in. Next pair. And this is again, we got this is a 45,000 square foot space with no columns in it. And this was our idea for doing it. It's a retail space, and basically the thing does 2 jobs. It advertises the home-based building, but it also holds up the mast holds up this great spine running through the building, and you can I think you can grab what's going on by the particularly, if you look at the next slide. You've got the weight of about 14 London, I think 30 London buses. Andrew Wally will correct me. I think he's here. Coming down those rods, holding the spine at just short of the halfway point, supporting that truss. And if Frank would like to put that forward, the supposition that the Trust would hold the building up without the mast there, I'd be very, very interested to hear from you. Next one.
Doesn't help in wind, does it?
It would do if you put a column
There is a column.
Yeah, I know there is.
And it's capable of taking tension.
I guess it's why it's there.
Oh, Tony will perhaps recognise this structure. This is our station roof for the terminal at Waterloo. And this is a kind of interesting operation because, of course, you would have the people who would say, why don't you do it the portal frame? Particularly QSs would say that, probably. And we wanted to do something very elegant, but there was some and really lightness has made the thing extremely efficient. On the left we generated it on Tony's computer, YRM, and on the right was our brass model simultaneously. And next one, it shows what's going on there. The interesting thing is you had the tracks were fixed in position. You couldn't shuffle the tracks around, and you had that outside train which had a sort of envelope around it of space which you couldn't go within. So we were very tight on that side of the site. You had to get the structure on the outside of the building there, but where we had space on the rest of the roof, we brought the structure inside. So we had a 3-pin structure with the members reversing onto the inside, and it creates a very elegant effect, particularly on the western elevation, which you'll be able to see. Next one.
Can you just stop on that? Because I think it's totally interesting that you possibly could have had a 3-pin frame with a pin central. Somehow or other, in fact, going off-centre, off the actual purist shape, you created something, I think, which is very interesting, which is away from the kind of purist form, although you might describe it as the simplest one and purist. But I think this is where structural expression comes out. It's not the most economic, the most direct solution. And this is kind of pinpoints it, to my mind.
But I think you'd have to fight quite hard to prove that to make it symmetrical it would be cheaper. I mean, I don't think it's necessary.
You see, the point was you had
cheaper.
to come up almost vertically on what you're seeing about the right-hand side. So if you then turned over and started to go, if you like, more or less horizontal across the roof, you'd start to have to beef it up.
You're using your site constraints to your advantage with the kind of expression that perhaps you're looking for.
Yes, well, it's a two-way process, I think is what I'm saying, really.
What's Tony saying?
We got something we got something out of it. But you didn't have, the other thing is, which perhaps I didn't say, is on the right, we had no thickness for structure there either. I mean, in terms of the sort of depth you'd need for a massive portalised column.
No, I think it is actually very elegant.
You're quite right to say that quite a lot of that structure is generated out of the constraints that we have. And one of the things, Nick, another constraint, in fact, is that, as you said, the tracks are completely fixed in position, and we have this very, very difficult tight boundary on the right-hand side of the right slide, and the question of having to fit that train in on that track. We also have the problem that the plan, the fixed plan that we have, is curved. It's not only curved, it's tapered as well. It tapers down towards the far end of the station. So that we've been trying at the same time to devise means of producing a structure whereby, oh no, there's one other constraint too, of course, and that is the existing arch foundations onto which we've got to found, which has given us certain grid constraints on plan. But we've been trying to find a structural solution which doesn't mean that every time you go from one bay to the next, the whole structure has to change, so it's a different fabrication. And we think that we've devised something which is, in some sense or other, at that offset joint can be telescopic. That's the right way to describe it, I think. And so you really need the whole model here, actually, to be able to look at the thing, but I hope you understand what I'm saying. And I think that, yes, this is a piece of structural expression which I think truly comes out of the problems that we have and out of the architecture that Nick wants. And I think it will be seen probably as such. Whereas some of the other things we've been talking about, I think personally, sorry, I'm now interrupting your talk, Nick.
No, you
but
carry on.
possibly,
Structure.
I mean, I wanted to talk about, perhaps I'll talk a bit about structural expression myself later on, before somebody else fires things at me, but I think some of the examples we see today of overt structures are perhaps too expressive, too dominant. Although, as an engineer, I get very excited, of course, about structure that you can see, but I do think that structure does have to have a certain logic about it. It shouldn't be too overblown, although I expect I can be accused of doing that sometimes. And it does, I think, have to have a certain relationship with the architecture. We're not just talking about building structures, we're talking about buildings.
Why do you think it's not a portal frame?
That,
Yeah.
it is a portal frame.
Oh, well,
In engineering terms, it's a 3-pin portal. Yeah.
it stated that just because it wasn't a portal frame.
No, I think that
Well,
was a misconception.
It's a complicated issue because this does actually need quite a lot of tying through the base.
So there's a portal frame.
Well, it depends on how you do it. I mean,
I think what
it's a sort of it's a complex.
It's a three-pin
portal, really.
structure.
Yes, but Nick, I think I'm right in saying that your reference to the portal frame was actually disparaging, not on the behalf of this, but that if some elements of British Rail were left to themselves, and certainly the property board, you'd end up with a Conda shed type portal frame. Is that right?
I couldn't say a word against my client.
Well, I could. He's my client as well.
Well, can we continue to the end of your slide?
I think that's it.
Is it?
Is that it? Is that it? Yeah.
Right. Well, I wonder if we can if there are any questions or that you want to address. I mean, I think it's quite interesting if we could, even at this stage, sort of raise questions, even among ourselves. Well, where are we going with all this? You know, are things doing anything other than just move along? Are we actually making engineering progress? Are we making architectural progress? Well, what actually is being accomplished in terms of a progression of an architecture? Is it moving? This is a question.
Can I ask something on that? It seemed to me from the structures that you were talking about, James.
Could you speak a little louder?
Sorry, the structures that James was talking about, the 50s structures, that what had been minimalised was the mechanism of support, and that the things that were holding up the building had been considered, in a sense, in isolation from the way the building appeared to the eye.
No, I don't think it did to the architects of the time. But they wanted actually, I think they wanted, or the ones we were working with in those days, wanted actually to express everything.
Right.
And including the cladding and the whole thing and the way it looked. They was very, very conscious, but there was virtually nothing added.
So they accepted the shape that the structure as a means of support generated. Because it seemed to me that what's different about these buildings we've been looking at is that the structure has been considered as a shape in itself rather than just as a means of support, and therefore somebody's looked at it with an aesthetic eye as well as a functional eye. Am I being unfair, Frank? Has there been a shift in attention in that way?
I think the architects today, in fact, are interested in the form of the structure. In the 50s, they were happy to get a job. If we could minimise the amount of steel used, the job went ahead. We got a permit to build. And the architects were terribly happy to follow through the actual minimum structure. Now, today, we have structures which are economic, but in fact the architects are, I wouldn't say distorting them slightly for aesthetic effect. And they're using structure as part of decoration and part of the total design. It's exposed. The Waterloo, as structure going above the roof on one side and not on the other. And they're actually expressing the structure in their own way to achieve what they want as architecture. It's kind of, before in the 50s, I think the architecture appeared with the structure. Now it's different today.
Before that, opportunities of people doing, expressing structure for the sake of architecture, distorting it, and bending it, and making it into things which are by nature decoration.
But you seldom have a chance to do a pure structure. It's always influenced by the site constraints or thermal response of the fabric, and really the opportunity to do a pure structure, a pure abstract form, hardly ever occurs. It's always bent by influences, by conservation, by the sort of materials that you can use. And
the nearest you get would be a railway station. And you can see the constraints you've got there.
But are there rules beyond functional rules?
I think pure structures are dull.
I mean, what rules would be invoked? I mean, Nick's putting the truss on the outside in one part of the portal frame and on the inside on the other part of the portal frame. I mean, why did you do that, for example?
So the train didn't run into it.
Well, I think that's not a very good answer. You could have made it a bit higher.
You could put the cladding on the outside of the structure.
But it wasn't a functional reason. I mean, are you really arguing it was totally a functional reason?
Well, that's what drove us in that direction, basically.
But you felt freedom to do that.
That's what you used to justify the...
Yeah, I mean, there is something more complex than that, which you've got to acknowledge.
The section is a reflection of its bending moment diagram.
It would have been
Tony
on the outside of it too.
will agree, which is why the tension rods which are running underneath reverse and go on the outside of the structure at that point.
Is that Andrew?
Yeah.
Thank you.
Where is it?
Yes, you're quite right.
Are they working?
No, look, it's wrong. You're getting really defensive. I mean, in a way, it'd be really nice.
No, I'm not defensive about it. I think
actually open up and be, which I mean, the 50s were wonderful in their self-criticism. Or self-reflection, or self. And I think, in a way, if it could open up so that it wasn't so defensive, it would be much more kind of interesting.
Right. Well, we'll make a demand for lack of defensiveness. Mika.
Well, I don't know if they are defensive or if they are implicit in their criteria, because it seems to me that the first presentation, a frank presentation, there was, sort things went okay in the relationship between the architect and the engineer, especially when the architect and engineer were frank and said it. Now, when they started to get in a slightly different and more contemporary situation, in which the structure might get a little bit decorative, then one sees the twinge, perhaps, of disapproval. And then we have the presentation by James, and James uses the word elegant. So what are the criteria which you have, which describe or ascribe to a structure to be elegant or not elegant? Because you do seem to have some criteria. And those criteria, I think, that were actually spoken in the last intervention. Is this an arch, or this is a truss, or what the hell is it about? And then they came out with 3 definitions. True to material, or, I actually did hear the echo of Ruskin at some point there. So do the engineers have some sort of criteria, hidden, implicit, or protective, that they use when they have to fight with their architects who want expressions?
Can I offer one person's ideas on that? There's a man, David Billington, whose book The Town on the Bridge looks at some of the late 19th century bridges and so on. And he offers economy as an overriding concern, and then thinness and integration, which I think was rather close to what you said, Nick.
The bridges are very different from buildings.
Yes?
Economy of what?
He's trying to define what he calls the art of structural engineering. Economy in the use of materials, in his case.
Well, I'm actually talking with this structural engineer, who are actually have you know, a lot to do with difficult architecture at times. They
No,
have
not
a lot
difficult
to do
architecture. Difficult
with,
architecture.
you know, some architecture which has been, you know, one famous building which is a masterpiece of contemporary architecture which Cambridge University wanted to pull down because technically it was not up to its support. So obviously they have also aesthetic criteria, because the word elegant is not just economic means, it's something more than that.
I think there are two elegances here, aren't there? There's an intellectual elegance which goes with the structure to some extent, and there's a purely sort of visual one. And I think probably the best structures are actually where everyone who sees it for the first time says, "My God, that's beautiful," and the engineer can explain actually, and you know that it actually has an intellectual elegance, that he has achieved economy, he has actually shown how the forces go, and there is a sort of satisfaction there too. I think if you get the two going together, and the suspension bridge, something like the Severn Bridge, is elegant in that sense. It has both an engineering elegance and a visual one, I think.
But the fourth bridge is very good.
The fourth bridge, I think, is well, do you mean the suspension bridge?
The suspension bridge, yes.
No, well, that's nothing like got the elegance of the Severn or the Humber.
But in
why?
David Billington's book, when he's talking about the John Roebling's big bridge, the Washington Bridge, he goes into Roebling's diaries in some detail and shows that even at the very limits of technology, Roebling felt he had a freedom of choice. It wasn't a technically determined solution, and that he was exercising that choice in the direction of this elegance, I think, as James has described.
You must confuse engineers who build bridges with engineers who build buildings, and there's enormously more complex problem building a building and working with an architect than actually going off on your own and maybe employing an architect to do the handrails.
I'm not sure that's true.
I think it's an immoral suggestion you're making there.
Can I just come back on one thing about this engineering? But I mean, I do think you get ultimately the best buildings when you've got an engineer and an architect working in harmony. And I think I've almost proved this at the last year's European Structural Steel Conference, because I thought it was sort of done fairly lightheartedly. But I asked 4 structural engineers to come up with a scheme without having an architect working with them at all, for doing the same site as we'd done the home-based building, 45,000 square feet with a clear span. And in theory, they had no help from an architect. It was an engineering solution. Now, one of the things that fascinated me most, that they were all considerably more expensive than our solution. The cheapest one was 20% more, and the most expensive one was double the cost of our structure, which I thought was very interesting, because if you might think that if you left an engineer on his own, he would come up with a really economical but maybe not useful solution. But that wasn't the case. And I mean, you can look up, because it's in published paper, but I don't think any of the solutions, with the possible exception of Marx, which actually was the one that was only 20% more, was
that was because the contractor didn't think he could build it for the price. The weight was too low.
But I mean, the interesting point was that I think that comes out of it is that it's when you get the two working together sort of harmoniously that you get the best solution, I think, and not either one in isolation.
But of course, it might have something to do with the way in which skills have been divided up, in which architects do sort of concentrate all on these articulations, and engineering concentrates on calculation, but doesn't have to be that way. But I mean, there is a focus on that. There is a focus.
It shows that architects are better at architecture than engineers.
No, the calculations come after.
Yes, I'm not talking about calculations in the... Okay, well,
I was in absolute enthrall. No engineer come up with
David, you've been trying...
I just wanted to say, relative to what Mika has said, that there seems to be a myth of purity. I've heard 3 or 4 people talk about pure structure. I mean, what is a pure structure is what I'd like to ask. And it seems to me to be like some clarification of this notion of pure structure that does not depend upon the relationship between pure and applied mathematics.
Anyone like to respond to the pure?
I think an engineer would think of a pure structure as one that, for its form, is the most economical in whatever category or criteria you guide it by. Be it amount of material used, be it construction cost. You can maximise it or minimise it for various things. But there are inherently better shapes for doing certain jobs than others. Somebody else was asking what's an engineer's ideal shape or ideal building. There are shapes which are better than others in engineering terms. They use less material just because of their natural shape. And that perhaps is what an engineer thinks of as a pure structure or an elegant structure, I think.
Would you
May
accept
I
that?
comment?
Yeah.
As an engineer, I don't think there is such a thing as a pure structure until you get to the boundaries of knowledge. If you do the longest ever bridge, you might get something fairly close to a pure structure because you actually have very few alternatives to your solution. You can still refine within bounds, as the fourth bridge and the seventh bridge show. The one refined by taking care of aerofoil considerations, the other didn't. And the result looks quite different. But the principles were, at that time, very much the boundaries of knowledge. They were spanning longer than they had before, and therefore they had to do it more or less in the way they did. I don't think in structure this applies. You have infinite solutions almost. Even for Nick's 42-meter span, that's no big deal in terms of what could be done. And therefore, it is surely then a question of synthesizing all the options so that at the end it looks as though it is actually the only possible solution. But I bet it never is.
And it's interesting that the seventh bridge is the one which needs a strengthening, whereas the fourth bridge is the one which remains.
I think we get a long argument here, and I think we ought to keep off with that.
No, we shouldn't, James.
No, that bridge was built before.
Because the whole point is that you were actually suggesting there was a separation between a visual formalization of what was seen and an engineering formalization. You were actually suggesting that the eye wasn't much of a feeder to the intellect. And it was a terrible suggestion that you made. It's very unhealthy. And back to the business economy,
I was trying to say.
The seven bridge is not economic, if in fact, as in fact it is. It is the one bridge in this country that is closed most often because of high winds, because it cannot carry the trucks across it that it was designed for, because they get blown over.
I think
the Humber Bridge does. No, I'm sorry. This is well, it is the most often closed bridge.
That's true.
And that is function
That's true,
of the
but
bridge.
The
function of the bridge is to carry the trucks.
It's not a function of the bridge.
Oh, I'm sorry, it is. Otherwise, they wouldn't. Otherwise, we wouldn't have paid for it. That's what the bridge. We could have had a tunnel. No use saying, and now we'll look at it. But it isn't intellectually pure because
it's what the trouble with it, and this is what Tony Flint said, who was doing the strengthening. He said actually it is the most amazingly economical structure. It was designed for the criteria that were set down by the Department of Transport, and so tight to this that when they actually decided that these criteria were wrong, and that in actual practice the vehicles bunched up and things, which was not allowed for in the design, in the ministries, in their rules, then it didn't work, because it actually didn't have a margin. It had no margin in any direction. I think I'm right in this.
Absolutely right.
But so in that case, it was possibly not an ideal bridge. It was incredibly cheap.
But one always had. It isn't cheap if it's only open 275 days of the year. And if engineers don't question the criteria of their clients, who happen to be in the Ministry of Transport, who happen to be spending our money, who happen to be equating it against putting a tunnel underneath, and do not say, who put a criteria through, who the engineers do not question that the fact that traffic might bunch up, might be blown over, and that bridge will only be open 275 days of the year, then it is not a well-designed bridge. And it's no use sort of saying, ah, well, visually it looks nicer than the Humber Bridge. You know, and I think to actually assume that the brain doesn't contribute to the intellect is terrifying.
What's it really trying?
There's often said profoundest condemnation.
Chairman, please. I must try and cool down this Ruskinian intervention here.
Right. Very simply, Cedric is saying that the engineers should question the architects much more.
No, the engineers should instruct.
In building.
Can I go one farther
No.
and say that the engineers and the architects should have questioned the need for that track hard up against the edge at Waterloo? Because I think this is uncertain. And St Pancras Arch was made because they wanted to move the tracks around. They never moved the tracks around since. So, but on the other hand, it was a marvellous advertisement for the Midland Railway. I think in actual practice, the Waterloo one probably is a marvellous advertisement for British Rail. And in that case, it pays for itself. But I think actually, you could equally say, compared with the Severn Bridge, that was it absolutely essential to have one of the tracks right up at the edge? I found it, difficult to believe that.
James, it's not there already. If you want me to answer that, I will.
Yes.
The fact is that it isn't essential because really, if they went the whole hog, they would buy about half a mile's worth of buildings all the way along the track and give it a bit more room. It'd be really nice. It'd probably only cost about £400 or £500 million, and it would really make the station look a lot better. But I mean, the fact is, life's not like that.
Well, it wasn't like that on the Severn Bridge. That's all I have to say.
Right. Well, we did hear last week that St Marylebone Station was one of the great achievements of the 19th century, economically speaking. It's the only one that we don't notice, but it was one of the, according to Robert here. But Mark, can I ask you? We've got to get moving on this because there's lots more to come.
Moving pretty fast anyway. I don't know where you wanted to get to. Yeah.
Certainly have slides.
Of course. Of course.
I'm with I'm fortunate in that I went to the Festival of Britain, so I'm old enough to have been there, but also young enough to have thought more about it. So I'll take us back a little bit further than the Festival of Britain, and I thought I'd show this little 1870s building, which is a little precursor really to Bush House. It's a bridge over a river in Paris, and it's a chocolate factory inside, and one of the first, I think, steel frame buildings or iron frame buildings that was ever built. But it's not so far away from the Pompidou Centre, and one could only criticise the expression of the structure here, really for the fact that they have little braces around the crossover points of the diagonals. But this structure is not a brick building, it's just brick clad. A little bit later on you find people like Frank Lloyd Wright subtly expressing structure. If you look carefully at the slide, I'm not sure if we can focus it or not, but you'll see that there's a tie ring around the inside of this roof. And that tie ring is in fact the tension ring to the thrusting forces from the roof. It's not been hidden around the perimeter, but brought in on little chains. And furthermore, the balcony you see underneath this roof is actually hung down on chains from the roof. There's a little problem in my mind about the size of the chains holding the balcony and the size of the chain tying the roof. There's a problem there, never mind. But you'll see here, we've always been expressing structure and finding problems with it. If you look at the problem that Frank Lloyd Wright found in the middle here, when he brought all these members together, his resolution next time round was to do it a little bit more differently. And there you have a real case of structural expressionism, because here you have a case where the problem has been solved. I mean, that's the structural engineer's problem, but also the architect's one. But trying to solve the detail of bringing all these necessary members together in the middle, he's resolved it nicely as far as the architect's concerned. But this sort of solution with a hole in the middle is one of the biggest headaches an engineer could ever suffer. Because what you get is enormous torsions going around this ring. And in this case, this ring isn't a pure ring. You have an enormous torsion which has to be taken out. Unless, of course, these arms are cantilevering. I'm not privileged to know that, but I suspect it literally is. As we have at the railway station, a 3-pin, I wouldn't say arch, I won't say portal frame. You can move on. I mean, I don't think this is necessarily structural expressionism, as some people would like to talk about it. It's more as necessity to solve a problem and do it in a sort of graceful manner, with a certain economy, without necessarily reverting to the form of the buildings which are more normal in this situation in Australia, such as these sort of alpine huts built on the same street. The truth is, here you have a ravine, it's 45-degree slope minimum, and one wanted to build a building which could be built on that site, which the client bought because it was considered a place which couldn't be built on. He built that house for £60,000, having sold his little Georgian terrace in Bloomsbury. That wasn't Bloomsbury, it was down in Stockwell. It wasn't that rich. But you know, this is the sort of thing you can do. The site cost him £12,000. It's a shame we wouldn't be allowed to build like this over here. But I mean, the other thing about this is, to be honest, that from a structural engineer's point of view, the case here wasn't a case of sitting down with an architect and dreaming up a solution. It was a case of an architect coming with a finished painting which he submitted for the Royal Academy Summer Exhibition. And that painting is not dissimilar to what you see here. And I say that with pride, because as an engineer all we did was make the idea work. And just work on it that little bit to make it possible. We'd split it was meant to be on this drawing, there's one member up the centre of the frame. We didn't want to make one great big long ladder. We didn't want to bolt it together there in a clumsy manner, so we just opened it up and made 2 members. I mean, thinking about detail, which is really what that last building was about, from an engineering point of view, you can take this detail, which is from the Haddisage building with John Pringle and Michael Hopkins, and in a sense this is a case of trying to do with, let's say, grace and elegance, a very simple job, which is build a round building on an old gasometer site, but unfortunately again with a hole in the middle. So we could have built the roof of the Albert Hall for the time we spent analysing the structure. I say that, again, it was about maybe 15% of the time we spent on designing the building, doing the sums, as people put it. It's a necessary task and a very informative one. But here you have a detail which is really, in some respects, very crude, but part of a building which is actually very, very elegant. I'm showing this one of a building with Benson and Forsyth, not because it's actually about structure at all, although it could be plain. I mean, it's impossible to really say whether it's structural expressionism. I mean, it's a column, it's a beam, the column's missing the retaining wall because, I mean, we don't want to get confused with the loading up the top of the retaining wall. The other side of the structure sits on a granite boulder, which is part of a glacial till in this Yorkshire site. It's just necessity done well. And this is a complimentary one to Frank's slide. It's the same architects as did the Doncaster job, but as Frank wanted to walk away from his Doncaster job, I'm quite proud to be part of this one. It's maybe overdone. I'm not sure. We could have built a swimming pool without an external steel structure. I mean, it's painting steel work when it's inside a swimming pool. And there was probably no need to mix timber and steel up. But having said all that, it's a nice solution, and it solves a whole series of problems to do with spectators being on one side of the pool and there being a very formal park landscape on the other side of the pool, which meant that you wanted a very low building on one side and a high space on the other side. So you've got a logic to making a form, which eventually sort of gives you a shape. The shape's not necessarily the easiest to build. It's not necessarily the easiest solution, but it's actually, at the end of the day, no more complicated than doing it in a simple manner. And then I sort of dropped down to detail again, because if you want to talk about engineering, you can't really talk about these drawings of sections of buildings and say that's engineering, because, I mean, where we spend our time when we're working as engineers is more in the detail than in the concept. You know, it's quite easy to have 100 conceptual ideas for a building very quickly, and we probably have at least 10 good ideas for everything you do. 9 get discarded, and 1 gets developed and developed and developed, and you end up building it. Sometimes it's on peril, because you find out all sorts of things about it as you go on. I mean, I could go back to the working one and point out the bits I had to add in to make the first idea work. But you know, at the end of the day, you've got to actually see it right the way through down to the final nut and bolt. And there's an elegance in doing that, and it's not a case of us sort of having ideas and passing them down the line to an architect who details it all up. It's a sort of case of making something work, and not allowing the architecture to compromise the engineering, nor allowing the engineering really to compromise the architecture. And I would think structural expressionism, if you want to put it like that, exists everywhere that people work properly together. I'm going to show a final slide which we all go back and look at, because if there's any good example of structural expressionism, there's this building. Architecturally, it's a disaster at road level, and that's been put right. But the fact is that this is a structural building. That it's also a very constructional building. It's a load-bearing concrete facade, literally bolted together on site, supporting what is quite a fine office space if anybody's been inside and looked at it, particularly if you think about having a view too. But I mean, it's suffered, unfortunately, to be sort of considered not appropriate, or inappropriate in terms of architecture. I would beg to suggest that if you really want structural expressionism, it exists, you know, you can find it anywhere, and particularly probably in the 60s, just as much as it did in the 30s, and just as much as it did in the 1870s.
Right, thank you very much. Right, well...
Can you pass a chair? People are leaving.
Yeah. Is David Dunster somewhere? Yeah. Is he? Would you be... Would you like to...
Yes, I might, but I mean, I don't want to
Do you want to say something?
I would like
in response to Mark?
I think so.
Let's see what comes out. Gordon, yes.
Well, I will respond in one or two ways. First of all, the matter of structural expressionism and economy. I recall the era of utility furniture. And the point about furniture is that one had to minimize on materials, but also that you don't put it inside containers or bridges or boxes, you put it inside habitable buildings. And therefore it seems to me that one has to have a certain liaison between the architect and the engineer, which I would like to develop briefly in a moment. Before doing so, I want to comment upon the spectacle I saw in Norfolk, Virginia, of lorries carrying what I thought were wooden beams. They turned out to be made of concrete with polyester fiber inside them because they were wobbling up and down like this. I could hardly believe they were concrete. They were intended for the construction of a new tunnel. I examined them. They were indeed concrete. Now what does that tell me? It tells me I can bend this stuff around like that. Isn't that beautiful? If I look back at the 1870s or even 1830s, I can see the precursors of Fuller or whatever, tensegrity and so on, in some of those beautiful diaphanous structures. If I look at minimalization, it can be of that sort, or it can be of the sort of clod-hopping sort, which makes structures which are, by all criteria of habitation, uninhabitable, by token of St. Louis. But the main point I'd like to make, and this is, I think, my serious point, is that in considering structural representation, structural expression, we have forgotten the fact, perhaps, or maybe have omitted the fact, that a certain sense of priority has been fundamentally reversed. Now, if I wanted to set up a house, I would get first a telephone, or a telex, or whatever, however elaborate I was, and build a carapace around it when I had enough money to do so. Previously, I would build a carapace, a hut, and I would bring in the telephone. Cedric would bear out my philosophy, I'm sure, on this, because we cooperated in a recent project, not terribly successful, but that was probably because we reversed our roles and he did the information and I did the architecture. And we didn't consult enough on the engineering. It's interesting that if you try to build an information environment in which we live now, I am an information engineer, I'm also, as a matter of fact, a mining engineer. But I'm an architect of knowledge. And herein is habitation. Herein does the beauty lie. Herein does the intellect, not the intelligence, the intellect reside. That is a profession, I do believe.
Thank you. Sorry, David, your slides ready?
Yep. I didn't want to talk about, I mean, I find the whole idea of structural expressionism terribly dull. It belongs to a period of dead architecture for me, when people were looking for some notion of truth vouchsafed by somebody else. And if I think about the notion of expressionism, I would say that which is the thing that would interest me most, it would occur in the 20s. This is Alfred Barr's cow of art and architecture. You'll see expressionism is in there someplace, on the left-hand side middle. And the kind of expressionism, which I find interesting, which I never find in structural expressionism, is, I don't know if the lights could go down a bit, this is an Otto painting called Homage to Beauty, that's great, is something to do with the city. Something to do with loving and hating it and finding it hard. This is Dix's very ironic object. And when I look at sort of buildings that are produced at the time of the Dix painting, like this Bruno Taut scheme in East Berlin, you can see that the building, I don't really think expresses any structure, but it's certainly modelled on the notion of Berlin. It has in the middle a wide boulevard, and then, which you see here, off that, a narrow street scaled to the normal street scale in the centre of Berlin, and in between that are allotments. Also something I find quite interesting. The building doesn't express itself, it does say something about the city. I think what is disgusting about the architecture of New Brutalism and structural expressionism has always been that it wants to produce an individual monument. It's basically greenfield site architecture, has very little to do with the city. And I find this very depressing. Having said that,
I think that what's happening to Nick Grimshaw's scheme at Waterloo is absolutely disgusting, but does indicate, in the sense of what British Rail want to put on top of it, but does indicate the absolute problem of a structurally conceived scheme. Because now there's going to be this awful office building on the top of it, which comes right through, which means that there's no reason anymore for this big span because of the big columns of the office, I assume. And I'd like, while I deprecate structural expressionism, but I love engineering, I'd like to suggest that now we start a petition in defence of Nick's building, because what British Rail is suggesting is just gross and has nothing to do with the city. Thanks.
Okay, now, would John like to join in at this stage?
Right. I've got some slides in the...
Okay, John Pringle.
Thank you, forward.
Yes.
Blue dot.
John Pringle.
As informative as ever.
Okay. Actually, I think structural expression seems to imply that there's a fantastic ready-made menu of structural ingredients that you can feed into your building. And in fact, we find this rather the reverse. It's we spend more time trying to get them out, because especially with our buildings, where we are have a very slim buildings where everything is taken back to the bones. One can't afford to have any structure which is in inconvenient places. I think the thing that's most important to us is actually the software aspect of structure. It's the way of looking at buildings to really achieve what you want to do, and to try and do what looks obvious and to then justify it later. It provides the software that enables the buildings to happen. And really, structural engineering is only one aspect of it. In our buildings, I think we'd like to see that structure is obviously a very important ingredient, but there's also the thermal engineering and the constraints of the site. And there's really a whole stew of things that you put all the ingredients in, and you let them cook during the design process, and they sort of come out with some ingredients that have been sort of boiled away over the process of the project, and there's just a hint of the flavour of them left, but some of them remain as very strong influence at the end. And structure is obviously going to be one of those things that remains throughout the project. In fact, if we take Lord's Cricket Ground, which is has some fairly expressive bits of structure above, apparently, to me the most wonderful bit of engineering is, in fact, right under the existing terrace, which, if we can have the next slide, there's when over that roadway, there's a lot of concrete slabs which were quite patently standing up for 100 years, and all the filler joists had rusted through, and really there's just a load of clinker which was standing up in space. And it was quite obvious it was working, but it was getting the engineers to look at it in a way that could justify that it would actually work. And what we found in the end was that, whilst if you're building it as a new structure, you would do it as a reinforced concrete slab. By analysing it as a flat arch, suddenly the whole thing can work, whereas it was a dangerous structure just 10 minutes before. And this was something that intrigued us. Then, when we came to do the brick arches, which was really trying to recreate the building as it had refurbished the building in the way that it should always have been built, we suddenly realised that there was quite a magic in what is really a pile of rubble. But if you put it in the right geometry, it suddenly becomes a coherent structure. And those brick arches there are all solid brick through and through. There's no concrete in them. And it's built as, what you see is doing the job, is actually holding the building up. I think if we can go on to the next slide. This is a building where I worked with Tony Hunt and Mark Whitby when Mark was at Tony's. And to me, this is something, again, trying to get something which is clear, which is legible, because I think engineers' first responses aren't always to provide legible structures. In this case, we like the idea of the 3-pin portal frame. This is the Patera building, which is a standard industrial unit. And we put the structure inside because it provided 1-hour fire resistance, the structure outside, so that the cladding would provide 1-hour fire resistance to the structure. But then the 3-pin portal frame is a very beautiful concept, but when you start to look at it in more detail, all the problems of wind uplift mean that all the load reversals result in a lot of bracing on the outside of the structure. And we really rejected the first responses from the engineers, and this really led to another way of looking at the structure, whereby you could get the beautiful 3-pin frame to work. And the key in it was the tie in the middle, which would make the structure perform as a 2-pin frame in uplift, as opposed to a 3-pin frame under live snow loads. And suddenly we could remove all that ugly bracing and all the sort of overstructuring on the outside of the building. And this was just the software was the thing that released the different way of looking at the building that suddenly makes it all work, whereas it didn't work 10 minutes before. And this was, in the end, ended up as a really quite a brilliant invention, which Mark patented. If we can take the next slide. Again, this is the David Mellor factory, which Mark referred to earlier. Mark was the engineer on this job. And there was another nice detail, in fact, the same detail that Mark referred to earlier. If we can go on to the next slide, which is the bearing detail. And the interesting incident here was that the district surveyor came back and said that that's overstressed. It's we had it designed as a leaf spring, whereby it wouldn't impose thrust into the perimeter wall, but would the wind loads could be taken out in the plane in the direction of the wall itself. And the district surveyor came up quite rightly saying that this was overstressed. And Mark's response was to demonstrate that actually, if it failed or became overstressed and deflected too much, the structure would work better. And the district surveyor, in the end, accepted that.
You could take a hacksaw to it and just saw it through slightly to reduce the stresses.
So, again, this is really engineering, where it isn't so much the hardware that's there. It's you've got to have the way of looking at it and the program that makes the obvious concept work, the thing that we all knew worked from the beginning. But it takes a lot more work, I have to say. But it's in the end you come up with something that's legible. And I must say that engineers' first responses are generally rather illegible structures. They work, they solve the problem, and you can design a 3-pin portal frame which has no pins in it at all. You can analyze it as a 3-pin frame, and it'll work as one, but it won't look like one. And really, there's no clarity in the way that it works. If we can go on to the next slide. Again, going back to Lords, this illustrates a preoccupation with the materials, where you have the materials in the base, which is a load of rubble, which is in compression and only works because of the geometry, working up to the top where there's a membrane roof, which is just a floppy bit of canvas, which is nothing unless you hold it in tension under a very specific geometry. And again, that's something that I think we enjoy, is the fact that the materials can take on a completely different character if you apply a geometry or a way of analysing them. Taking the plate girder zone, which is just below the roof, that in that case, the key to that was fire engineering. And this is really a tribute to Margaret Law of O'Arab and Partners, who, and a lot of our buildings, including the Patera building, really owe their clarity to the fact that you can get rid of all the fire protection. You just look at it a different way. You analyse what the flame temperatures would be coming out of it. You can analyse what the stresses are, and then you can show that what is a structure that you know works in the first place and is a very clear statement will actually work. But it takes a lot more of the software to do that. If we can go on to the next slide. Again, the Schlumberger building is really just another illustration of the fabric, which is a non-structural material, except if you hold it under a very specific geometry. And this the structure really there is generated by trying to build an impossible diagram. We had a diagram where you had small cellular spaces on either side and a very big open interior landscape space in the middle. And the solution isn't in the abstract. One wouldn't start off with something like that as a pure structure, but it's a response to all the requirements of the site. You've got your diagram that you have to build because it works, and you have to come up with a slightly funny structure, and perhaps more expressive than one that didn't have those constraints. I'm going to go on to the next slide. Again, something that interests us. This was a Bracken House competition scheme, which we work with Mark again as the engineer, where we were trying to take the exterior architecture inside, and that was taking those Lord's flat arches in the old slab. We created jack arches inside, which are basically a flat structure with materials that wouldn't be load-bearing unless they were in that format, and that links through to the structure on the outside. And on to the next slide. And this is the actual Bracken House facade, which was modified. And when we had to retain the building, you get another influence, which is the fact that you have to retain an old building. You've got materials, and there's the whole conservation problems to address. And really, the materials here generated the structural form. The facade is load-bearing gunmetal on load-bearing stone. And this, in fact, it probably isn't a million miles away from centre point in terms of having the load-bearing facade, but it's something where each material has a conviction because it is part of an overall structural system which also extends inside the building. On to the last slide. And this was a competition, in fact the Peters Hill competition, where we were taking the services into the facade, and the structure was bent by the fact that we had these snorkels which took the fresh air for 100% fresh air cooling scheme right down to the basement plant rooms because we were constrained by St Paul's Heights. And this created a structure which was also part of your environmental control system. And so there's no such thing really as a pure structure. It's all influenced by, the structure is one element, but you have to read all the other factors that are going on at the same time. That's all I've got.
Right, thank you very much. Ron, do you have any slides? Ron? No. No, you don't. But, okay. Right. Is Cedric Price anywhere? Yeah. Do you have some slides?
I have some slides at the end of what I'm going to say.
Do they have them?
Yes, they have them.
Do you have them?
No.
Okay.
Just going to talk now.
First time ever.
What?
Don't have any slides.
No,
Right. Cedric Price. Is that loud enough?
I like that last contribution, sort of Pringle pudding in a mixture. I like that. The very last building reminded me of the work done by James Stott, the architect, in the 1860s in cotton mills, where in fact all the extract, rather than the input, all the extract of cotton dust-laden air was carried out through the vertical cast iron columns, which had a great effect on their diameter, but also increased their stiffness through the diameter being increased as such. And the one before, the gunmetal and inevitable pink stone, was an interesting example of really paying attention to that overrated architect Albert Richardson's original building in those bay windows, the faceted windows and the pink thing. So that was dressing the pudding, whereas the last one was mixing it. And I thought the Lord's one was an interesting example of what the point we were trying to make is that you can't actually, in the terms of tonight's conference, actually define out individual elements and say add them together and then they tell the whole story. I just feel that it's been very nostalgic this evening, and I hope that most of us have a little bit of investment in the future. I thought I'd make the following points, is that I believe that engineers who are consulted by architects, such as those here tonight and they we speak about, I personally think engineers should have social intention, full stop. I also think that the direction of such intention should be assessed by the architect, not tailored by the engineer. And that's what makes you choose an engineer or reject one, and it may be what makes an engineer choose an architect or reject one. And a good example of what I mean is Peter Duncan. He made no secret of his social intentions and his appetites. I believe such engineers should have hunches, and they should be prepared to back them. I believe such engineers should delight in their own capacity to change their minds. And I think at the moment there's a danger that the dependence engineers take on various forms of computerization reduces their own capacity to change their minds drastically, as opposed to change their minds on a piece of paper. And there is a danger, I don't think any architect wants, well, let's put it this way. I think most architects would like to work with an engineer who is prepared to change the menu of a meal rather than become a bespoke tailor, which is a difference of when the alterations are made, when the decision is made. I've got a feeling that there is a danger at the moment that engineers are being driven into ingenuity rather than rethink. I'm encouraged if such engineers still hold, and this comes back to Gordon's point, still hold interest in, it also comes back to Stephen Keats' point, but they held interest in some of these items. Now this is a very personal statement. We're keeping it 10 minutes, I thank Lauren Anna for speaking. But I'm interested in engineers who are concerned, not necessarily finish up with it, but are concerned in structures of least weight. I'm interested in it. I'm interested in their concern about lifting and moving, whether it's in assembly or disassembly. I'm interested in their concern about shortage. Here I think one can quote Samueli. Now, whether it was imposed on him through the fact that at the end of the war and during the war, almost all materials, but particularly steel, were rationed. I'm interested in calculation, which is where I broke through when all this chat was going on about, and I think, Chris, we should take this up about Hans Stanton, which certainly had nothing to do with concrete. You remember how the portal frames sprung apart by Someone died, or is that 10 minutes? You know what I mean?
It's a signal.
Right. And I'm also interested at the same time the Maison Jarre, and then the not long after the Frank Newby exercise and calculated load-bearing brickwork, all of it 3 stories high, never mind the Monadnock building 100 years earlier, going up to 70 floors. I'm also interested in visible structures, which takes up Prickle's point, in so much as when he was saying pretty useless material unless you put it under tension, Schulenberg. Well, actually, the same sort of fabric is also a very good structural fabric if you introduce an absolutely invisible key structural element, which is air pressure, which you can flavor, it can smell like violets, and it still hold the building up. I'm also interested in the limitations, which is why I had a go at, I say I was feeling rather like Oldham City then, having a go at our distinguished Mr. Sutherland, Professor Sutherland. But I do think that, that something like the Humber Bridge has been given far too little attention, and the Severn Bridge has been given far too much. I do not understand that. Engineers seem to like the Severn Bridge, and in a way, not really want to know too much about the Humber Bridge, which I find far more interesting. I'm also interested in the other quality of expediency at the time, which I would suggest is what the Fourth Railway Bridge was about. And very interesting too. And it comes on to a point which I would like to take up in discussion, is the whole misapprehension of the value of the tubular structure by engineers when they're told it's architecture and not bridge. And I think the breakthrough here is actually, fun enough, within the oil industry, the North Sea oil industry, who have advanced the whole technology of tubular structures, the jointing, the calculating of transference of stress, and in fact the value of tying what architects would see as disparate foundations, as long as the ground's deep enough and we put a tie, we don't need to tie it at that level. The whole business of tubular structures, I think, has got something to do moving from expediency to the experimental. And the experimental and expediency, I think, was brought together with Shortage in something which is still there. The very first one, well, I think the first one is still crossing the Trent River just by Barlaston. The second one is still at Christchurch, which I saw yesterday, on the Bailey Bridge, which I think is an absolute classic. And it's the trial Bailey Bridge is still there at Christchurch in Hampshire. The construction time and the whole business of manufacturing time, which was absolutely critical, something like Bailey Bridge, is forgotten in relation to something like the Humber Bridge, and certainly, to a certain extent, is hidden by architects into other timings, which I think is a great pity. And I think it's also an element that should be introduced by architects, by engineers to architects. I think engineers have a responsibility to remind architects about the efficacy of accurate timing in both design, construction, useful lifespan, and demolition. I do not think that engineers at present involved with architecture have many of these interests in heart, and therefore I think it's a rather sad period. That it's the start of the 90s, and all sorts of things can happen there. They reach intensity. How about the...
You've only got a couple more minutes.
Yes, I've got 2 minutes for the slides.
Yes.
I would like lastly to say that three things I enjoy being involved with most in relation to engineers. One is the Medway crossing. Two is a 75-metre mobile gantry, which is both parallel and radial in movement. And third is an absolutely nutty discussion I had both at Poole and in Bournemouth over the last 2 days with these people doing vertical, rigid sails for boat propulsion. Now I will have the slides, give me a minute and a half, which will remind what I've just told you. Right? Yes. Yeah, he's absolutely not. Very interesting. Maybe wrong. Can we have them both on at the same time? It's all right. Lifting. The assumptions as to what you lift, the height you lift it, and for how long it lifts. The only point about one on the right is that two cranes were used to build a third crane, which was high enough to put things on the post office tower. And it was higher than the three. Next. And it was on rubber tires. Don't forget what's underground, and don't forget what we're putting underground or undersea and its size. Next. Mobility. The object of mobility is less important than the intention. On the left, he liked the house, didn't like the view. On the right, 1908, a mobile Zeppelin tent, all wood and canvas, and it could move almost as fast as the Zeppelin itself, pulled by Next. Building and demolition. Remember the cost of removing the waste. Quarry Hill. Photos by Sea Price. Beautiful. All right. Next. Urgency. Let's always wait for the disaster. Let's plan it. These, I might add, none of these slides are criticisms of architects, they're all criticisms of engineers who don't really seem to remind us about these things. Next. This is for Roy, the appropriateness of design. Next. The appropriateness of siting and for how long. That's a floating island on the right, and that's a floating travelling family on the left. Next. Packaging. It's worth knowing how much the eventual product requires in its packaging, whether it's a chip or a set of goods for a quite small Midwestern house. That's it. Thank you.
Thank you very much.
Engineers, please note, all of them.
Can I ask whether anybody other people have got slides in the projector that I don't know about? Has anybody else got slides here? Ah, Mike, would you?
Where'd you get that,
I'll talk briefly less time than Cedric. Got a bit of face that we'll see what's
I didn't take long. I took 10 minutes. Watch it.
Okay.
Well, really just a series of questions and things I like. 1509 to 1515, John Wire, the fan-vaulted roof at King's College, Cambridge. Why did he do it? I think he did it because it would be beautiful. And I think he did it because it performed the task that he set out to achieve. Next. 1851, Decimus Burton. Why did he do it? I think he did it because it was beautiful, and I think it set out and achieved the task they intended. Next. The most important house built in the 1960s in the world, Steve Baer's house, which is the precursor of the second industrial revolution. This was a steam radio valve version. We're talking, of course, about the electronic revolution. And this was the manual Victorian way of trying to attack the problem that we're now really trying to grapple with. Why did he do it? Because he was fascinated by the structural system. He was an engineer that the house is built from, the zone system. And he did it because it was beautiful. And he did it because he was concerned about its performance, as did John Wyatt and Decimus Burton. So I would offer the notion of performance as a judgment of structural quality. Next. Discontinuity here, of course. Lloyd's, our own building. Why did we do it? Performance. Not a direct link, I have to say, not because it's beautiful, I have to say, but we're finding it increasingly difficult to separate a mid-blue custom-coloured piece of steelwork, which we call structure, from something which we might call servicing, from something we might call floor slab or space. In other words, we see them increasingly as integrated systems. We find it very difficult to see them as separate pieces. So we're wrestling with the problem of integration all the time. And here, the reason for Lloyd's is that plan. That plan is what generates everything else in the building. That is what Lloyd's is about, that plan. And it's about performance and growth and change over time. The ability to accept that certain parts of that structure will be expressed in different ways according to what they will be doing over the next 150 years. Or 10 years, depending on how long the building will last. We certainly didn't intend the coloured pieces to last a long time in their current form. In fact, somebody, I think last night, in fact, raised the issue of the problem of Lloyd's when it's listed, as I'm sure it will be in the end, and what you do with all these changeable elements on the outside of a listed building. I think our solution is to list all the elements separately. Next. Just again, an illustration of the performance. The middle slide on the right really illustrates the yellow, which is the main block of the building, which is the human housing element, and all the blue is just that which supports it. Next. Again, performance. Conflans Saint-Honorine, a skating rink, beautiful little structure, it's been around for a very, very long time by Kefelec. A bat lives in a hole in the ground, and when the sun comes out, the bat automatically rises, stretches its wings over the stadium area and covers the ice to keep it out of the sun. And everybody carries on skating, and when the sun disappears, it disappears back into the ground again. Of course, to great cheers from the crowd as it happens.
Get a word from Jenny Lowe, and maybe a word from Peter Salter just towards the end, if you would agree to that. So, could I first of all perhaps go to Robert Thorne, and ask him if, I don't know whether you particularly want to address these issues, but it would be nice if maybe we could round some of these questions up.
I'd just like, as the only historian in the kind of front stalls, to pick up on a couple of things that people have said this evening, and to reflect very briefly indeed on the character of this event. First, I think as a historian I can't accept Mark Whitby's proposal that structural expression is always with us, nor can I really accept Ron Heron's proposition that everything's going on at the same time, because I think you called us all here this evening in recognition of the fact that something rather special has happened in English architecture in the last decade or so, and that it isn't just simply a rehearsal of things that have been going on for a long time. It draws on certain antecedents and a certain pedigree,